Recycling plastic is complicated. Separating it out, carrying it to the curb, gross. And even worse, sometimes it's actually better for the planet to just send it to the incinerator. There has got to be a better way. Can we really recycle plastic? It depends on what you mean by plastic and what you mean by recycle. So yes-ish. There are 7 main kinds of plastic, each with its own recycling story and issues. And that's part of the problem. You have to separate them out for recycling to have a chance at all. So let's do that. Let's just talk about the number 5s, polypropylene. The molded plastic from your butter tub, yogurt cup, sour cream container, and all this stuff. The recycling story for polypropylene is about to get a twist. Polypropylene is a polymer made up of a chain of hydrocarbons. Polypropylene is so hard to clean that it will never be reincarnated as another butter tub using current techniques. What are some of the challenges with turning recycled polypropylene back into consumer products?
If you visit a recycling facility, it kind of smells like vomit.
The trouble with polypropylene from the recycling standpoint is that when you fill it with stuff, it gets stinky. And that's because all those products, your yogurt, salad dressing, peanut butter, soy sauce, and soap, leave behind different organic molecules. Molecules like diallyl disulfide, which gives garlic its smell, or eicosapentaenoic acid, fish odor. And as those residues break down, they give off even worse smelling compounds like butyric acid, which you might recognize as the barf smell, because it also shows up in your stomach when your food digests. And those nasty smells stay in the polypropylene. That's because these flavorful residual molecules are themselves often organic molecules made up of hydrocarbons, just like polypropylene. And hydrocarbons love hanging out with other hydrocarbons. The residue molecules are smaller and can squeeze their way between the much bigger polypropylene molecules, which is where they stay. Without some deep cleaning, and I mean a molecular level of cleaning, it's still gonna smell. One thing you can do with polypropylene is downcycle it. Grind it up, melt it together, and mold it into a shape. That's if you really don't care about the smell. Even after it's degraded, the polypropylene holds on for dear life to most of those yucky smells, and also all of the original colors from its source material.
You often get this black material from mixing all the colors of the rainbow together.
I don't know about you, but there is no way I'm gonna eat yogurt out of a black plastic cup with a whiff of barf to it.
Maybe you've made a black trash can out of it. You don't mind that it has this really rancid odor, but when you're using a bottle of shampoo, you want to make sure that shampoo you're putting on your head is from a package that is clean and safe to use.
If you want to take your downcycling to the next level, you can try pyrolysis. Pyrolysis starts with using heat without oxygen to break those long molecules apart in a brave effort to separate them from all of those embedded impurities.
You can think of it as 3 steps: take the molecules apart, purify them, and put them back together again.
It takes a lot of energy to heat up that plastic enough to break down those bonds, and you have to burn fuel to make that energy. Besides all that fuel you burn, one product of pyrolysis is carbon dioxide. Pyrolysis leaves you with pyrolysis oil. Either it's converted directly into stuff like diesel fuel, waxes, heating oils, and some industrial chemicals, or it's treated and cleaned some more, molded and cooled into solid pellets, the raw materials of new plastic containers. Pyrolysis is not only more expensive than making new plastic, at the end of the day, pyrolysis gives off almost as much CO2 as sending those containers into the incinerator to make electricity. This is recycling? Before you get too discouraged, the twist. It's called dissolution recycling. Dissolution recycling keeps the molecules whole and uses a special chemical solvent to remove every contaminant embedded in the plastic. And I know I said we couldn't just wash away all those impurities, but it's all about the chemistry of this special solvent, which is a liquid alkane. Alkanes are another kind of hydrocarbon that consist entirely of single-bonded carbons and hydrogens without any other functional group attached to them. The single bondedness of alkanes makes them stable under some pretty extreme conditions, like really, really high temperatures and pressures. They won't break apart or react with other molecules to form new compounds. And when you manipulate the temperature and pressure, you can make them do different things, which is the key to how dissolution recycling works. In the first stage of dissolution recycling, you combine the dirty polypropylene solids with the solvent, and you start to heat it up. As the temperature rises, pressure keeps the solvent liquid, but most of the impurities can't take the heat. They melt, separate from the polypropylene, and dissolve into the solvent like salt in water. Then you can just pour it off. In step 2, you add more solvent and raise the heat even higher than before to where the polypropylene itself dissolves. The last of the solid impurities get left behind. From there, you let the solution cool. The polypropylene solidifies and you pour off the solvent. So you've switched it up. After removing the contaminants from the polypropylene, you then remove the polypropylene from the rest of the contaminants, all thanks to one stable but adaptable solvent. You're left with pure polypropylene that gets molded into pellets that are indistinguishable from new ones.
Almost like magic, it's transformed coming out as this snow white, clean, pure material.
And it takes only about half the overall energy compared to just making pellets from scratch. So is it possible that plastics, or the number 5s at least, could become an almost totally renewable resource? That would finally make lugging all those containers out to the curb worth it. Why are you so passionate about this? Why do you put the hours and years that it takes into developing something like this?
I really enjoy applying good science to things that you can walk around the grocery store and see, and there's just a lot of fun in that.
This is recycling. 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 This is recycling.